Hello, Internet. Welcome to Fully Defined. My name is Chris, and tonight I'm continuing in my Build and Learn series here, modeling this Lego motorcycle that you can see on screen. So far, we have done many parts. You can see the ones marked in green. We either had them already from previous projects or we needed to make some edits to get them going. Some we modeled completely from scratch, such as one of the tires here, the rim, and quite a few other parts. You can see them in previous live streams. The intent for the series is to live stream the modeling of a majority of these parts and then also live stream the assembly. The assembly I expect for this project to be a little bit more complicated than the previous models we've put together. Particularly this gear chain setup on the side. So there's quite a bit that we'll learn through that process. Now everything will be made available to download by the time we get to that assembly point. So if you are interested in taking part, following on either live or on a replay of the stream, if you sign up for the email list, you'll get access to the library, which has a lot of the parts, all the parts that have previously been done, and particularly this Volvo wheel loader that you can see here, which is the off-road at the bottom, and the front loader off-road buggy and quad bike. They're all available at the moment. The motorcycle is the next one on the list. So yeah, jump on the email. You can also check out the school community. That's just getting started. So I don't have too much in there, but we have a couple of the classes. So the Build and Learn series for the wheel loader or the off-road buggy, everything's there in a sort of session class format. So everything's in order. All the resources take you through the whole project. So some great free resources for learning SolidWorks. I've done enough talking to no one. Now to start the stream, let's get into some modeling. I have with me, in front of me, right here, all the parts that we are yet to model. This one's done. I'm just going to try and get through as many as I want tonight on stream. And then when the stream's done, I'll probably finish off the rest. Because in the next live stream, we're going to start the assembly. So if anyone does jump on, viewers, hello to my one viewer that's on right now, but anyone else jumps on, feel free to hit me up in the chat with what parts you would like to see me model or any questions along the way, and I'm happy to answer them. For now, while there's not many people watching, I'm just going to try and smash out the easier ones. Okay, get through them as quickly as possible. So, got this piece here, these three, and then this one on the right. They're my easiest couple of parts. I'm going to start with those. All right. That'll be a little warm-up. This one will then lead into these two parts here, and hopefully by the time I'm doing those, there might be a few more viewers. I'll get into some more complicated models. Hello, Edward. Thanks for jumping on the stream. Hope you're doing well. Okay, let's get started. Now, for reference, I use Rebrickable to work out the names of my parts. It's a great resource to see images of parts, what they're worth, different variations, numbers, and that sort of thing. So if you were following along, that's where all my part IDs come from. All right, let's jump across and start modeling. Now, the first part we're going to do is this tiny little circular one here. Now, I can't, unfortunately, my Zoom is offline. I couldn't get that working. So, I can't zoom in on these. Actually, you know what? I've already got that part done. It's another one we can tick off. Very good. Move on to the next one. Edward, if you had any requests of parts you'd like to see me do, feel free to let me know. Next one on the list, this black one. We also have this done. Great. tick that one off. That one is right here. Then I've got this circular one. I'm pretty sure we don't have this. Or it's close, but it is different. But we can use that to reference this one here that has the hole in it. Okay, so we will do that. Meanwhile, I'm going to see if I can get that camera zoom working. It's this camera hub that doesn't want to open up. All right, so that file, if we have a look at the part itself, what I do is I grab the name. And I'm grabbing the name because I'm going to save this as a duplicate part. So I'm going to open up the original file. I'm going to save as a copy. But when I do this save as, I want to make sure that I'm hitting the box that says save as a copy and open. So it's saving like a duplicate. I can rename it. All right. Tile round 2x2 with hole. And it's going to open up a new version of that. So it's not overriding the existing one that's already in the assembly. Close the original document. So this is the new file. I'm going to change over to the default configuration without color. And now I can just do a check against this part to make sure the dimensions are right and that nothing is too different between them. I think it's going to be a pretty obvious one. So I've got my calipers here. I'll just get those on. Okay, so outside diameter 15.8. We see 15.8. So I'm pretty sure that is all going to be the same. I think the only difference will be this hole gets punched through. So we'll just check that dimension. See 4.85. And we have here 5 millimeters. So we're going to thin that out. 4.85. And because that is done in a cut, I'm going to reuse that sketch. So I'm going to select the sketch contour, or I'm going to select the sketch in the feature tree. Then I'm going to hit my shortcut key for cut extrude. I'm going to select this contour in the middle, and I'm going to go through all. And that saves me from having to create a new sketch. All right, so select the plane, new sketch, convert edge. Instead, I'm just using the existing sketch that's already there, and just saves me some time. Now, if I look at this part on the outside here, it does look like a pretty sharp edge, so I think that's fine. We can save this. And just before I put it into my assembly, I'm going to create a configuration which is dark grey. This is how I get all my different colored parts into the assembly that share the same geometry. And I want to apply this to the part file. So I'm editing the current appearance. I'm going to go to plastics, medium gloss, dark grey. Press OK. If it's too dark, I'll fix the colors later on. And then as I'm working on the project, I simply insert each version of a part into the assembly and save so that it's there when I've completed modeling all the parts. And that's how we go through this process. So another one ticked off here, and we can jump onto the next one. Hello, Ashish Sharma. Welcome. Do you have any requests for parts? You can follow the link in the chat to this Google Sheet. You can select one of the orange or yellow parts. I will model that next on screen. Otherwise, I will continue on with what was planned, which is this one right here. Okay. It has, let me show on a larger screen right now. So it has a bit of a profile to it. It has the axle shape going through the middle, but it's a relatively simple extrude. All right, very straightforward kind of part. It does have a little kind of marker on the outside you can see there, kind of catch in the light. But yeah, this should be very, very straightforward. So let's do this one next. First, I get the part description here. Ashishi, I am from Melbourne, Australia. Where are you from? Thank you for the question. All right, we're going to start a new part file for this one. And I'm going to do it on the front plane. And let's go about measuring. Looks like it's flat on the outside walls. Yep. 6.96. I might round that up to 7. It's actually taller in one direction. It's a bit different. Or maybe it is a bit round. I actually think it is round. 7.2. So it's a bit hard to see in the detail. India. Good to hear, she. All right, so it is round. You can see this face here. This is flat. And I can really tell it's flat because when I catch the light, you can see it's consistent light across that whole face, from one side to the other. All right, whereas when I look at this side here, if I try and get the highlight, try and catch the light here. And see in this example, the highlight is a very thin line. Okay, that tells us that this is a curved face. All right, so a little bit different. Nice detail. So I'm going to start this one with a circle on the outside. That circle is going to be the diameter, which is the wider section, which we've made it at 7.2. All right. And the next one is going to be the flats. So the flat section from side to side is 6.75. So what I can do here is just put a sketch in on each side. I could do both sides using a mirror and then a dimension between the two. And that gives the flat edges that I've just been showing. Okay. Now I'm going to trim that sketch. All right. So I just want one single profile on the outside. Now, next step is going to be the inside face, or these channels, because it's not round all the way through. It's, I've got a curve and then a step. So I think I should actually model that detail, but we'll do the inside at the same time. Now, I suspect that the inside is the same as many of these axle holes, but it's 4.9 across. Now, this one's a bit bigger, so that's interesting, 5.15, 5.15. Those axle holes are always a circle, so I'm going to sketch that in. And then for the shape, I'm going to put a corner in like this. I'm going to make that equal. I am going to put a very small fillet on the inside, so it's got a very tiny radius on that inside face. I'm just going to put that in here before I pattern. Okay, and I'm going to select chain, do a circular sketch pattern, and make sure that these are referencing the origin, and then I just have to dimension between them. So I'm going to go top to bottom, from side to side. Now, if they're different, I'll have to change how I've done the sketch. But this is where it's challenging to measure because they are so small. I believe they're going to be about 1.9. Yep. 1.9. So I dimensioned one of them, and because they're all equal, that's going to be fully defined. Now, this sketch, should I trim this? Yes, why not? We trim that. Okay, we've still got a fully defined profile. Next one, now we're going to do these side areas. Okay, so for this, it's very difficult to measure because it is so small. All right, if I could zoom in even more, I would. Because it's got a fillet in that area, best I can probably do is try and measure at the top edge. It's about 3.4. And then I'm going to have to gauge the internal radius by eye. 3.4. I do have a radius tool, which I have used in the past. However, it's not very big. Okay, so it only goes up to or down to an R1. All right, this is 3D printed. Just a little set. Now what I can do with this tool is grab, let's say, the second chip, which has an R3. Okay, so I've got R3, R3, and I can actually fit this in the gap here and see how that fits. Now, if I get like a good fit, that's giving me a good guide as to how big that radius is. And you can see on this that there's nearly no gap, whereas if I put the R4 on, a bit hard to see, but there's a tiny gap in there, right? So I think we might have found the radius. So 3 there and 3.4 from side to side on the outside of the part. So let's use those details and put that in. Edward, great question. Using the tool I just showed you is one way. Alternatively, like when you're measuring something like this, it's incredibly difficult to get it accurate. For what I'm doing here, it doesn't matter if I'm 0.2, 0.5 off, but if it was important, then I'd probably do like a prototype test fit. I might 3D print a jig or something like that to test the part to actually get the perfect match, right, if it was really important. All right, so how are we going to do this next section? It's not really a cut down, it's just a radius that comes in. So what we're going to do is get an arc tool, go from one side to the other. This arc has a radius of 3. Right, just work that out. And now we just bring it back. I'm going to select the arc and select the sketch pattern. And like I did with the other ones, I'm just making sure the center point of that pattern is on the origin. And now I can dimension between 2 points to say 3.4. And what else can I do? I have to line them up, right? So if I grab, let's say, this point and this point, I can make them horizontal. And that's going to fully define that sketch. And then I can trim away the excess. I'm left with a single sketch, basically profile, ready now for extruding. There's no other detail on this. There might be a fillet on the very ends, which we'll put in a second. The width of the part is 15.8. I'm going to extrude it. 15.8, I'll do it mid-plane. And I will put those small fillets on the entry face. So I'm going to select this face and this face here. And that is my completed part. Technic axle connector smooth. Save that. And it's a grey part, so we'll just leave the colour as is for now, and I'm going to insert that into my assembly. Tick it off the list. Ashi, how to download STL files for practice? Okay, great question. So if you were to go to the description of this video right now, I'm just going to jump on to show you. And go to the description here. If you follow the references here, you go here, it says to download any of the SolidWorks files, sign up to the email list. So this will take you to my kit page. You can sign up. Following sign up, that'll give you a link to a Google Drive. In that Google Drive, you'll find the files that are available. At the moment, we only have, for this project, the SolidWorks files. Let me just double check what we've got. It's a great question. Thank you very much. Yeah, so that link will take you to this Google Drive. And if you're trying to get STL files, which I don't have, but I do have step files, you can go to the step files folder here. So everything that has been exported as a step file from the first two projects, the Volvo wheel loader and the off-road buggy, you can find them in this folder. And you can download those, insert them into SolidWorks, and then find the associated lessons. This is the next level thing, and follow along with the process, or follow the rebuild process for rebuilding a step file. I would suggest on the channel, if you go to the live series here, actually go to the playlists. You can find this off-road buggy and lesson 6 here. This one shows you how to insert, download and import a step file, and then recreate geometry based on the step file that you can see in front of you. So this is a really good lesson for anyone wanting to learn how to download and recreate geometry based on an existing file that is not parametric. Great question. Thank you very much for asking. Okay. Now the next part we're getting into is this one over here. Now there's two versions of this. There's a light grey and dark grey. And if I show you here, you can see why we're doing this one next. So we've just created this one, which has that kind of step profile. Now I need to create these two parts, which are identical. They're just different colors. This one has the same shape on one end, but then it's got a circle cut in the middle, and the next side is coming off at a different angle. So we're going to take this one, save a copy, and convert it to this. I'll show you how to do that. Let's go. Right, so the file that we're going to do is, we'll do the light grey version, this one. Technic axle and pin connector angled. On that, look, it tells us the angle here, so that saves us a bit of time. 157.5. That's also why it has the number on it, number 3, to identify that angle. So I'm going to open the part. I'm going to go Save As and save as a copy and open. Control V for the name. We'll see if that saves. If it does, fantastic. And yep, here is the new version. So the old one has been closed. All right, so now we can work from this. So first step to work out where to put the circle element. All right. So how I think we should do it is we should make the circle, the center point, the origin. So first step, I'm going to change this extrude to blind. And what I'm going to do is to work out where the center point of that hole is, I'm going to measure the diameter, internal diameter, which is 4.9. So half of that is the middle, okay? 4.9, which makes it 2.45 to the middle. And then I'm going to add 2.45 onto this dimension from this inside to the outside, which is, looks like 9.5. 9.5. All right. So 9.5 plus 2.45 is how long this part is. Now that's the end point. Then here on the right plane is the center point for my circle. And what did we say? This was 2.9 on the inside. The outside of that section, the diameter, you can see is 7.3. Sorry, that was the radius, so times 2. Now we have 7.3, the outside of that. And we can see it's just over the outside of the original shape. And the width of this part, this detail, is 7.8. So here I'm going to extrude mid-plane 7.8. Now what I'm going to do is uncheck merge result. I want to practice using a tool that I rarely use, but I know exists because I've seen others use it. And that tool is the intersect tool. So on our features toolbar, it's here, intersect. Intersect surfaces, planes, and solids to create volumes. Now, I've never really learned how to use this tool properly, so let's do this together. We're going to select these two bodies. And then I think what we're going to do is create intersecting regions. I suspect that's what we want. Press intersect. And now I can see the different bodies, all right, that would be created by that. I've got 1, 2, 3. And I'm going to preview the included regions. So that's the regions that I want to include. Now, I wonder if this is going to work. When I select it, it's hiding it. So does that mean I'm getting rid of it? Let's press invert selection. I believe this is the result we want, so I'm actually just selecting the bit that I want to remove. That makes sense. I do want to merge result. And then press OK. And there we go. Let's remove the part of the body that was on the inside that I don't want, and it's merged everything else that's remaining. Now, I can't actually see deep in this to see exactly what it looks like down there, but I'm going to assume it does come to a stop, very similar to that. So that was cool. We will use that intersect tool more and more as we get used to it. Now I'm going to roll down on this fillet feature and just remove the dangling edge here, the missing reference. Because I'm about to pattern this, but I don't need the fillet that was on the other end. This is fine as is. Which software is better, SolidWorks or Siemens? I can only tell you about SolidWorks. Sorry, I've not used Siemens NX. I'm a SolidWorks expert, and I've never even seen Siemens before. Sorry. I would say that if you become very proficient in any of the CAD software, you can use most of them. I prefer to be an expert in one so that my knowledge is deeper and it becomes faster and faster. Hello, I'd say. Thanks for joining. What are you up to on this Sunday, I'd say? And that's Ace, congrats again on your number 2 position in the World Champs. 2. Well done, mate. Very tough and unfortunate, in my view, on that failed model, the one that crashed. You could have been a world champ. Stick at it. You might be next year, next time around. But you did really well, mate. Was very impressed. All right, so let's finish now this part. We have the angle because it's been given to us on the image here, 157.5. That makes it relatively easy. So I'm going to do a circular pattern. I'm going to select the entire body. I'm going to select this face as the area to revolve around as the axis. I'm going to change the instance to 2, and I'm going to change the number to 157.5. Press OK. And then with this, all I have to do is merge the 2 bodies. So I go combine, I'm going to add, select them both, press OK, and that has merged that into one. Now, if I didn't have the angle, the way that I could work it out is to put this upside down on the surface. All right, so put this on a flat plane like this, measure the distance from the top of the body to the flat plane, create a construction sketch, and that would tell me what the angle would need to be. So that is the other way you can work it out without having it given to you. I'd say thanks for your answer for Ashishi. I've never used Siemens NX, so I could not tell you anything about it. Now, there is some detail left to go for this part. That is the step down that is in this central area. That step down is 4.9 millimeters, and I believe it's a millimeter deep. I'm going to create a sketch on the face here with the diameter. What did I just measure? I measured the wrong area, sorry. That was the inside. The step down is actually 6.1. That makes more sense, 6.1. It even looks bigger than that. So I've measured the outside at 7.3, 6.1, what's that, 7.3. Yeah, the inside dimension is wrong. We need to fix that one. The inside there is 4.9. Few typos today. That's why things are looking so funny. And that's affected our intersect, so we have to roll back. Come back to our intersect here and just select the other region that we want to get rid of. That's pretty quick. The pattern, we'll just do that again. No problem with that. Then our hole, I'm going to cut that down 1 millimeter. So back to blind 1. It might be a bit less actually, but 1 looks about right. And we'll mirror that onto the other side. Okay, and save. Now that part is complete. We're going to save 2 configurations. So we're going to configurations, we're going to have grey, which is the current color. And we'll also do a dark grey, let me rename that. And in this version, we will change the appearance, make it a bit darker. Like this. So we have a light and a dark version. There we go. Insert that into my assembly. And that is another 2 parts ready to go. For the assembly. All right, let's tick that one off. And then take requests. Here we go, guys. Take your pick. Which part do you want to see me doing next? Well, you guys have a look. I'm going to tick off the list. So we've got another 2 done. This one done. And this one. All right, we're getting there. This is all we've got left. The rim. I assume you mean this one. Edward, thank you. Thank you. All right, let's do this. Now, this is a version of a part that we have already done one of the rims, which is here. And I have some similar details, but some differences. Yeah. So on first things first, I think they're the same diameter, as we can see here. So that's going to save me editing and mucking around. Obviously some similar details. Okay, they have the same sort of axle hole through the middle. It looks like they have the same pattern here and the same ribs. I'd say even the depth of that face inside looks the same. The whole pattern looks the same. What's different is that this one on the left has this extra layer, extra thickness. But I think if we just chop it off, that's going to be exactly the same. On the sides, the outside looks the same. The gap we can see there that the revolve step is the same. It's the gap in the middle that is reduced. And because of that reduced middle, that doesn't have these ribs going around, so we can get rid of those. On the reverse side, it is the same detail. So Edward, this will not be a full rebuild model. This will be an edit of the existing model, but I will show you how I modeled the original one very quickly. It's a great point, I'd say. Extended sticks, yes, you can measure from a longer region. All right, so let's have a look at this part before we save out the duplicate. I'll just get that file name ready. this one here. All right, so save as, and then I'll show you the steps. Okay, so how the original was built. It started with a revolve, and in the revolve I got really the majority of the detail, and I did this in a single sketch. We have a look at that sketch. You can see I've got the arc up the middle. All right, this section here. Let me just turn off Instant 3D so it's clear. All right, so I've got that arc. Now that was a part that I left underdefined until I'd done more detail, and then I refined the exact position. But everything on the outside I could measure. So the 20mm, a lot of sections here, a lot of diameters. All right, so all of that went into a revolve. That revolve was then followed up with, I focused on one side first, which was, I believe, the one with the pattern and the ribs on the outside. Now I did split some of the features in from one side to the other. It's just the way I decided to build it. And I did move some things around later on after building it to make it a bit more efficient. So those holes and those ribs were all done with a circular pattern feature. And then on this side, this detail done with a cut. And then finally the rib on the outside, which was circular patterned. So now we're in the duplicate part. Let's work out what we're going to remove. First up, we don't need this rib on the outside or that pattern. So I can just delete that straight away. Next up is the overall width. Now, I can see in both versions, it looks like the detail on either side is the same, but how far it is from either the top or bottom face changes. In that, if I just slice them off, I think we'll be pretty close to what we need to be. So I wonder if we just try that in the first sketch, what's going to happen? Let's give it a go. So this is where the Instant 3D can really work, because I could change a number like the 20 dimension and everything will update very quickly, but it does depend on how you've done or set up your sketches. So you can see here, I've got this to 10 dimension. Now that 10 dimension works in this original, but if this number here becomes 14, all of a sudden that 10 is not going to work. All right, and so I get the error. So what I might be smart to do here is to edit this original sketch, and instead of the 10 dimension, actually work out a different way to fully define that element. And what that looks like is this is already fully defined actually to the length. I think it's just the radius of this that needs to be controlled. And I can control the radius either with a simple dimension like this, put that in as a 50, that might do it, but this is no longer on the midpoint, so that could be wrong. Or I could, like I can fudge it a little bit, I can change this one to driven, then I can put this point onto the midpoint of the line, and now it's fully defined. No one's going to notice that 0.04 of a millimeter difference. Now, if I'm to change that dimension again, the 20 that we see, let's go into 16. I'm still getting some errors. I'm still getting quite a few errors, actually. It's not going to work. We're going to have to I'm going to roll back to the original sketch, and I'm going to edit this one manually. Put in the numbers that I need. Okay, so outer diameter or outer width of this, 14. Okay. And then the key dimension that's changing is this area in the middle. Now the depth remains. So if I was to measure this, how deep it gets, am I getting accurate dimension? Pretty close, about 26.7. What was it here? 24. Am I getting all the way in? I might not be. Yeah, I'm actually not quite getting there. Close, but not quite. I think it's this angle that changes dramatically. All right, so it's still the same kind of shape, but instead of coming at like a gentle angle, it's just really steep in here to then a flat face. So the gap between those two faces, 1.75, 1.8 millimeters. Now that's going to be here. That's going to become 1.8. So let's bring this to 14. And let's work out how to change those angles. Now I'm just going to roll back, turn that off to work out what's driving these angles here. I can see that I've mirrored. So everything's mirrored across that. Okay, so this one was parallel with this line on the outside. I'm going to delete that relation. That's going to free up this to shift. I also need to shift this 5 dimension because that no longer remains the same. So I'm going to make this one driven. That enables this to shift. I'm going to set the depth of this one to 1, the height. So now what can happen is this can shift out and keep the thickness. I can then change this dimension to driving. Check that dimension again. I can see it was 1.8. So here, I'm going to type this at 1.8. And now let's see what happens when I put the 14 in this time. Much closer, right? Everything is looking much more aligned to what we might expect. Going to accept sketch, zoom out. And that's looking pretty close. Now let's roll down some of the features and see what happens. So we have the axle shape on the other side. That's here. Now, one new thing with that is it should actually come out much further in this example. It actually protrudes from that top surface. So while the whole width is 14, at this section, it is 14.9. So this one, I'm going to change this feature, offset, reverse the offset dimension, and press OK. Now, so long as we're on the correct face to do that, that'll work really well. Roll down the next feature, which is this one. We might come back to that. I think that we'll edit this one actually. This one was offset quite a long distance. I think it's fair to say it's not going to be that far. And if I use my calipers right on the edge there, I can just get it on this element. 3 millimeters offset. So I'm reducing that. That looks better. Now I've done a cut there, which will make more sense in a section view. I think we will update that. So that's going up to a certain plane. We'll come back to it. Then we're doing a through cut this direction. Yeah, so this had a cut that goes into it, which is 3.6 now. Reduce that one. All right, now we have our hole that goes through, so that feature remains the same. We have our ribs here. Now these ribs, where previously they got cut down quite a bit, now those are going to come up. They're not going to be offset at all. They're going to be from the sketch plane. And they will also include the additional contour, which I'm going to have to update. So to do that, I'm going to edit this sketch. I'm going to grab this edge here. I'm going to make it for construction. I'm going to grab this edge, convert it. And if I'm looking at how this original sketch was done, what I want to do is get rid of these, make them for construction, and just extend this one up. Now that has affected my geometry, but I just have to add a coincident relation back here and here. And those are once again fully defined. Press OK. Now you can see the contour goes all the way to the edge. Now in the previous example, this one, those had a bit of a curve to them, but in this version they're flat. So I no longer need this cut revolve. So I can delete that feature and the sketch, roll down on the pattern, roll down on the final cut extrude, and that is a completed part. Edward, if you're still on, what do you think? Nice little workflow to get through a complicated part, but using existing geometry to rebuild, save time, and do something efficiently. Hope you enjoyed it. Thank you for the suggestion. We are definitely getting through a good number of parts. We're an hour into the stream, and we only have 10 parts left. Not sure if we'll get through them all today, but that's okay. Close this one off and tick another one off the list. Is there anyone else in the stream watching that would like to request one of these parts? Please let me know. It is hard to describe them, but if you try your best, I can pick it out. Oh, Guntis. Thank you very much. I really appreciate that. Guntis, should have you know, you are my first ever super chat. So, really appreciate that. That is a bit of a thrill. So thank you, mate. Thanks for jumping on the stream and putting one in like that. It looks like it worked. I don't know where. I guess it all totals into the monetization of the channel. So I guess I'll see it at some point. I'll let you know. Yeah. But thank you very much. If you want to pick apart Guntus that you would like to see me model next, here is the options. There's a couple of different ones, a couple of easier ones. The tyre would be a similar thing to the rim, which we just did, because I've already got a tyre. Just needs a little bit of rework. These two are quite similar. I think I'll be doing those very fast. These are all quite similar as well. This one's going to be really challenging, quite small. Yeah, nothing here is too difficult. All just Lego pieces. Awesome, Guntus. Glad. Feel free to test with me anytime you need. Thanks, mate. All right. I'm going to try and do these two. All right. We do have one of these, which I think is already done. The smallest one there, Edward. Edward wants to see this one. This one is the chain part. It's tiny. I think I really should get my zoom working on the camera first before I do this. So Edward, I hear your request, but I'm going to have to troubleshoot the camera zoom off screen before I do this. So we'll hold fire, and I will do that one another time. I'm going to jump onto these two now. We have done similar before. You can see this one right here. Okay, so in fact, that is one of them. We've done that one. I don't need that. But I need to convert that one we can see into this, which should be straightforward. Yeah, black one's done. Okay. There's just this longer one. All right. That is this part here. Technic being quarter ellipse thick. Let's save it and have a go. So first, save as a copy as always and open. I'm going to overwrite or create a duplicate, save as, new name. And now with that done, I can make the changes. Let's go to the default configuration and let's have a look from the top view. So the differences between these two is pretty obvious. They have the same corner detail. Okay, so they've got the same axle in the corner. It's got the same sort of curve, different number of holes. One up, the same, but 1, 2, 3, 4 instead of 2. If we've modeled this a certain way, it would be very quick to change. Let's see how quickly it will be. And it all comes back to, this first sketch. And unfortunately, it looks like we haven't made it with this kind of part in mind. That's fine. I'm going to edit this sketch. Actually, turn on Instant 3D. Hit this one here. And I'm going to measure the new length. which is 39.2. Now, 39.2. What we would expect here is that if we add plus 16 onto this, that would be the new size, which is right. So for every hole or slot in Lego, it's 8mm. So that makes sense. Now, what I do need to upgrade is the number of holes, but I change the instance here to 5. And that's going to update those holes. And then I'm going to roll down. And the reason I use the rollback bar in this instance is to remind myself of how I built it, so I can make any changes as I go. Also, if I have any errors, I can just quickly allow for them, like quickly make any adjustments without seeing a huge list of errors in my feature tree. So often, my models will have hundreds of features, but I can limit the errors by just quickly manipulating certain elements of that tree, either sketches or features. It just makes it easier to manage, right? So here, we've got, what's this, cut extrude thin? I think this is where we're doing these holes. All right, so on this one, I just need to update my feature. So it's using the same sketch. It's got the same pattern. So this cut extrude is using sketch 1 that's used here in the tree. All right, so the sketch has already been updated. What I need to update here is the feature. I need to select some more contours. So I'm going to select these additional 2 contours. That adds those 2 contours into this feature. Means there's not much more I need to do except roll down for the mirror, and now it's going to update on the other side as well. So very quick workflow to mean I can keep moving on. Now this one's a bit more complicated. In this one, I have to do a few more of the offsets. So you can see here I've got this offset 0.5 from this edge and this edge and this edge. So I'm going to select, well, I suppose one way I could do this is with a pattern as well. So why don't I change it? I'm going to delete that one. I'm going to leave this one as is and put that back on the edge, go radial. This one here, I'm going to select it and do a linear sketch pattern on. Now the distance is 8, but I'm not going to dimension it because I'm just going to use the center point of one of them here and move that back. And that's going to fully define it. Right, now that's created all the contours that I need. So I'm going to accept on the sketch, edit the cut extrude, and change my selections to include these additional 2. All right, so that updates. Right, that cut extrude. The boss extrude here, I'm going to have to change again. But you can see how this is being built. It's a pattern centered on this circle. If I delete these coincident features, I can move. I will be able to move. Delete that. Let's try that again. Delete the co-radial feature. And yeah, I have to delete these coincident features. I can move that all at once over to the end one. And once again, make that sketch co-radial. That's moved that little plus, that axle shape for me down to that back corner. Now the mirror here was for those cuts. There's an extruded thin, which I'm going to update. So that one is going to come to this center point. All right, that just creates the little solid between those 2. And then the fillets will be the last one to update. I'm going to edit the fillet. Now for this, I've got a lot of missing edges. I'm going to clear all missing references. I'm going to select one, and I'm going to use this shortcut bar to select the rest of them. Now I just want to get the right faces, which is, it's kind of all the internal ones, but I don't want the ones in the axle hole. I might have to just remove those manually, but I'll do that after selecting on the other side. So same again here, get all those, manually deselect these. It's still a quicker process doing it like this. And OK. And that's our finished part. Ignoring the decal on the top, we may do decals in another lesson. And I'm going to add a configuration, dark grey, update material, another one off the list. Save and insert. There we go. All right, we are getting pretty close. What is left on the list? Not many. The beams here, the red ones, they're going to be pretty straightforward. We've actually done a very similar one to this previously. This is just a configuration update, so I don't think there's too much to do on those. This one's too basic. Here I'll do that off stream. This one very similar. Probably do that off stream. Really, these ones are the ones that are left. I think we'll do this shape here as our next part. It's got some neat detail, some pattern features. It's a simple, it's a beginner type part with some extrudes, some sketch work, and some offset geometry. So let's do that. I'll just take a second here, say hello to anyone that is watching. It's jumped on the stream. Good to have you. My name's Chris. This is Fully Defined. I'm in the middle of modeling this Lego motorcycle. We are towards the end of modeling all the parts. These are what's left, the ones that are orange and yellow. Once we've modeled all the parts, we're going to do the assembly, and that's going to happen in the next live stream, whenever that is. Might be later this week, maybe Tuesday or Friday. You can sign up to get access to all the files, all the SolidWorks parts and step file parts. Just follow the links in the description, sign up on the email list. They'll give you access to a Google Drive. In that Google Drive, you can download all the part files and follow along with the project live. Or if you're watching the replay, you can do it at your own time. Okay, enough of that. Let's do our next one, which is here. So this part is called the Technic Cam. Now, why I've moved to Rebrickable for this series is they actually have a bit better information than the other website I was looking at, which you would see in my earlier series. So this one shows the part identification, the year, a lot more information about where the part's from. Usually some high quality photos of the part that give you even a better view than what my camera can do. My zoom isn't working today. But you can see the detail here in this one. There is a little fillet on those edges, actually most of those edges. There's a cut profile going through the middle. So yeah, and I get my file names from this as well. So let's start it off, and with a new part. Now we need to pick an origin for this. The origin of it, I think, is pretty obvious. You'd either pick like the center point of this top axle or the bottom, and I'm going to choose the bottom one. The overall shape is a little bit complicated to measure because it is round like that, but I think we'll be all right. We're going to do it on the front plane, and we'll start with that axle shape. So I'll just get that in place. As usual, it's going to be like 4.9. Now it's got a little extra cut in there, so that'll be a bit longer. It'll be 4.9 by 1.9. So I'll create that shape. Now they're actually round. So we put this shape in. We're going to put a small radius on this. And then we're going to do a circular pattern of those sketch elements. Make sure that they're on the origin, and then put in that dimension 1.9. All right, so that is our axle shape. Now on the outside of this, there is an arc. We're going to sketch that with a circle, and we can measure from one to the other. You can see it's 1.3 mil thick. So from this inside face, I'm going to hold shift when I click, and shift click, and then I can get a dimension between those two circles. 1.3. Now at the top end, do we have another circle? I think we do. And its diameter would be 15.5. If we do, we will see 15.5. And then we can measure the total length of the part, 23.5. So I'm going to hold shift, click off to the side, and then set the center point of that circle to vertical. All right. And then there are some curves going around the side. So let's try that with an arc. Now it's important that the arc doesn't drop on this marker, because that'll put a coincident relation to the center point of the circle, or a horizontal relation. So I'm just going to drop it below that and above one here, bring it out, then select the line of the arc, make it tangent, make this one tangent. I can then mirror. I've got it on both sides. And now the tricky part to try and define it. Now, I don't know if there's any real way we can measure this. We don't have a series of radius tools. One thing you could do is like sketch a line. So if we imagine there was a line going through the center point of this, for instance, and we could measure that diameter, then that could help us. For instance, we could set a few points, and that will give us a guide to how close we are. It does kind of look like this slot here is actually in the middle. That would help if that's correct. I think we could put those in and do that pattern, and then we might come back to the outside shape and fully define that afterwards. So let's leave that one underdefined, and let's put in the other shape. Now, I'm going to trim away this one. And let's think about a way that we can duplicate this detail. I'm going to select chain, so right click, select chain, hit linear sketch pattern. Now by default it's going to the x-axis. I want to go on the y-axis, and we can measure elements of this to work out where the center point will be, because we know that the width of this is 4.9, right? So if from outside to outside then is 20.9, we can take off 4.9 and that will give us the distance, which is a very neat 16 and makes a lot of sense if you know your Lego. I am going to dimension that one. All right. Now, the next two, I wonder if that is 8mm difference between them, because that would make a lot of sense also. So 12.9 minus 4.9, 8. Which means this one here, if we select chain and we do a linear sketch pattern and we change this to 4mm, that's going to give us the spacing for that one. Now, I didn't tick the dimension box, so I'll just do that again. Uncheck, check, dimension 4, flip, direction, okay. There we have it. Edward, that's a very good comment. Sketch picture tool. So how that could work, let's use that as an example right now. First, I'm going to save the part. Okay, next, I'm going to take a screenshot. Now, this is where if I had my zoom working, it would actually help a lot. I don't think I can bring up the camera tool because I already have it open in OBS Studio. I think it will tell me no, it won't work. Yeah, I can't do it in my camera tool. So I can screenshot from my OBS Studio, which is pretty small, but we'll do that. I'd much rather do this on a better zoom in shot. Okay, but there's our image. Now I can go to my front plane here and go insert, tools, sketch tools. Actually, I want to create a sketch first. So front plane, sketch, tools, sketch picture. I can then go to my screenshots, find the screenshot, press OK. All right, now you can see it's such low res. I need a higher res image for this to be accurate. But then I just scale that down, and that's going to help me get my sizing right. And you can see from this one, even though I don't have it perfectly lined up, I'm actually pretty close. If I was to edit this sketch, for instance, you can see that those arcs are reasonably close as is. So I might give those a dimension 30. I think that's looking pretty good. Let's hide the sketch picture and keep going. Thank you for the suggestion, Edward. Smart tool. All right, let's trim away this section. We don't need that. Let's also trim away this bottom section. I'm not going to trim these. You can trim the patterns that can create some errors. Let's just see what happens if I went and trimmed all the way through. I think it's probably going to end up with like multiple sketch contours. You see how they overlap here? So we'll see if that becomes an issue. The only other thing that I need to include in this profile here is the tiny little slot that's at the top of this. I'm going to put that in. Let me just have a better look on camera. It does have a round to it. Like a millimeter wide. .6 from that next one up. So we will sketch up, around, down, put the dimension in. So the radius is 0.5 and it is 1.6 from here. And if we make these equal, all right, that gets it fully defined. All right, so now everything is in one solid profile, excluding the overlaps that we've got in these sketches. Now I can press extrude and I'll have to select the contour, but I can now do a mid-plane extrusion. And that's going to be, let's say, 4 millimeters. And that's the base of our part. Now the next level of detail is the steps down. Now this is a different sketch. We're going to do it on this face. Now the first one is a slot that we can see. So around here, it's kind of a slot shape detail. I'm going to do a slot that goes from the center point of this one to the center point of this one and out. I want to then dimension outside to outside, 7.5. Dimension there. All right, that slot is fully defined. Now around the outside of the part itself, there is a wall thickness, 1.2. So for that, I'm going to select tangency, press offset, put in my dimension, press OK. And now I've got that shape done. The last one down here, there is a circle. Now I can't measure a diameter of this one. I can get close to a radius though. I'm going to eyeball it, 3.8, which would make it 7.6. And then in the section here, there is a straight element above that slot, which is 3.1 millimeters wide. So for that, just a straight line. All right, fully defined. After mirroring, let's make that 3.1. And all you really want here is the recessed area, a contour to cut down, which we've got. I can measure the depth, 1.4. So now I'm going to extrude cut 1.4 millimeters, and selected contour is going to be these two sides. And with that, our part is just about done. I'm going to select this feature and use the front plane to mirror. So that puts it on both sides for us. And then from there, we could put a bunch of fillets on, very small fillets on the edges. let's put those in. I think there'll be 0.2mm fillets. I'm just going to select the entire face like this. The part's finished. Let's insert into the assembly. And that is another one ticked off the list. What did you think, guys? Any neat tricks in that one? I think having done a lot of these parts now, we can see that there's a lot of repetition in the features. It's only in the really different kind of parts, more complicated ones where there's some different tools or workflows being used. You could do lots of these in very similar ways. Use a variety of different SolidWorks tools. Yeah, I think we're just about ready for the assembly on this one. Looks like we've got this one done already as well. I can see that here. So that's another one off the list. So this one, nope. It's this one here. So that's done. Tick that off. Glad you are, Edward. Yeah, I'll make sure the stream that I set up for the assembly, I'll do a lot of prep work for that. So I'll have all the step files, I'll have all the SolidWorks parts, make sure they're all available, everyone will know where to get them. So when we do the assembly, hopefully it's a bigger stream, a lot more people might jump on and have a go at doing it at the same time. Just trying to work out what other parts I'm trying to get here. These two are pretty much the same. I was trying to find that 3-beam one. I think I've got it actually here. All right, so I've got a 5-beam version, and I want to convert that to this 3-beam version. So I'm just going to save that name, copy that name. I'm going to go save as on this part. Now this is one I'm actually going to save over the top because it's the only example of it already in the assembly. So it doesn't matter if I overwrite here. And what we're doing is converting this to one that's got 3 holes. Can't find the part. Somewhere here. I know in the list there's this, here it is. Now we need one of them. So we do need it anyway. We just need to drop this down to 3. Very similar process to what we saw earlier. I'm going to reduce this by 16. What happened there? And I'm going to reduce this by 3. I do have to spread it back out to get that on the end point. And then I have to update. This feature remains the same. I'm using all 3 holes. Mirroring the same. This one becomes different. I'm going to get rid of these 2 that I don't need. Don't need that one or that one. Can get rid of those 2. And then I just need to update the contour. Only take these 2 contours. Update the fillets by removing all the missing ones. And roll down. Part's done. Save. And this is already in the assembly. That was the last one that I needed to edit. Everything else for the assembly is kind of new from here. So all of these are geometry is ready, which means I may as well delete that folder. So they're all the parts we've got in there. So I was going to show for my last one on the stream today, this one here. So this is a combination of the part we just created plus one of these. Can't find the part. It might be, oh, here it is. Okay, so we're going to show another little sort of quick hacking type of example on this one. So we have this, and we have this, and we want to create this, which is pretty much that element on the end combined with this one here for these 2. Okay, so how to do this in SolidWorks is, firstly I'm going to open this one, and I'm going to open this other one here. We can see it hiding away. This is a Technic bush. And what we're going to do is the insert part method, right? So I'm going to find the part here, which is this. And I'm going to create a new part file and give it that name. So I'm going to save as. I'm just saving the blank file just so I've got one open and ready. Make sure I put it in the right folder. Okay. And now I'm going to insert first part that I want, which is this one. Now I'm going to do that upright. I'm going to uncheck most of these options. I'm just going to include solid bodies. I'm going to press OK. And it's inserted that part. And now I'm going to insert part again, find the bush. Now I'll do the same thing. And what we can see is that it's going to drop it at the origin. All right, so if I press OK, it's dropping this part wherever its origin is, right, which doesn't work perfectly for us in this example. If I edit this in context, I go to this part file, I can see that it was extruded off the front plane, so it's not mid-plane. Should we change it? That's one way of addressing it. I wonder what would happen if I did just change this one to mid-plane. It kind of ruins a few things. Now let me reload so I don't break it. Hello, Leaky Gasket. Thank you for joining us. I'm showing you how to combine a couple of parts. All right, now we don't have to edit the position of the original. All right, we can leave that as. Let's say it has to stay where it is. Now in this version, we want it to match. All right, we want this one, which has a width of 7.2 millimeters, and this one, which has a width of 8 millimeters, to have the same width. Now let me check some measurements. This should be, it is bigger. So here, at this sort of section, it's 7.3, 7.2 in the other one. What's this one here? 7.4 with a sticker, 7.4, 7.3, 7.4. But at the end with the bush, Technic bush, is bigger, 7.9, basically 8. So it is thicker there, and you can, if you look very closely, you can see that step. That step is 0.4 of a millimeter on both sides. So the dimensions are right. Let's assume they're right. I'm going to move this one. So there's a few ways of moving it. Now I can do it manually, or I can do it when the part is inserted. In this example, because this part is 8 millimeters and this is 7.2, I want this face to be 0.4 mil offset from this face. So I'm going to edit this feature. I'm going to locate with Move Copy Feature. I'm going to press OK. And I'm going to add a constraint. And this is where you can add a mate in a part file. So I'm going to select this face and put a distance mate in 0.4 and flip the dimension. And that's going to reposition it for me, offset from that face. I press add and OK. Now you can't see a feature in the feature tree. It is underneath this drop down, under the Move Body Copy feature, and you can see there the distance mate. And that mate, even though it's a part file, that is editable, so I can change that distance at any time, like I would any other feature. Very handy. Okay, so now that we have that feature inside this part file, we have to edit this to get it to work together. All right. So what are we going to do? Well, first step, we're going to cut. And we're going to cut away from this top face. I'm going to convert entities, and I'm going to do a new sketch, which goes from the middle of that up both ways. Trim everything else. And I'm going to do an extruded cut that goes through all. And I'm going to select just this body. All right, so I've trimmed away the bit that I don't need. Now I exit isolate, and then we can see what we're left with. All right. So now I get to join these two up. Now one thing I've just noticed in this part here, you can see it's got the slot detail on the top, where you can see in my model, my slot is on the side. So I also have to rotate the part. Now, again, there is a way to rotate it when you insert the part here, but there is also a way to add a rotate separately later as another feature. And that is with the Move Copy Body tool. So insert, features, Move Copy, it's here. I have it hotkey to Alt M, use it all the time. I'm going to select the body, and this time instead of a mate, I'm going to press Translate Rotate, and I'm going to rotate this one, and I could show temporary axes. You can see this line here, that is a temporary axis. All right, so that's this button here. And then I'm going to rotate it 90 degrees and press OK. Now the slot's on top. Again, very handy tool for hacking a multi-body part. Okay, now we can finish the rest of this. So what we are going to do, we can see that this has a wall thickness of 1.4, which is thicker than this section. So here, if I measure, that bit there is only 1. So we're going to have to change that. So we're going to tweak a few things. First, I'm going to delete face on the radiuses that are inside there. Then I'm going to, on this face, do a sketch. And on this sketch, even though this has a diameter of 7.4, on the actual part, I want it to be 7.8, which is the length of this one. So I'm going to draw a straight line out here, do my semicircle, and join it up. I'm going to put the center point on the origin where it should be, make this one horizontal, and I'm also going to just convert this edge and then extrude it. I'm going to extrude it 1.4 millimeters to the inside. All right, now we might do some adjustments after this. We are going to merge bodies. And now we can see some things that we need to change. Now, first thing, I need to get rid of this. So I'm actually going to change the sketch contour that I selected here. Just delete it and make that this inside face. All right, so it's going to fill the whole thing. All right. It's actually filling up a bit of the slot. That's fine. Leaky gasket. Your question is good. It depends on the complexity of the part. Some parts I've done today on stream, which take 5 minutes. Other parts, like the really complicated wheels or the rims, they can take half an hour. And it depends how accurate I want to be. But great question. Thank you. Continue with this one. So I also want to fill in this gap here. So actually I'm going to edit this sketch again. But instead of having the line finish on those points, I'm actually going to select that edge, select this line and make them collinear. And that brings it all the way out. And then drop this one back so it is coincident. Right, now it's going to fill in that section for me as well. Okay, and we're going to do the same thing on the other face. Now let's see if we can do it with a mirror. We do have our front plane here. So if I select it too and press OK, we get that nice filled in surface. That's looking pretty good. Our slot's kind of not working so much anymore, our hole, but we can fix that. I do want to change the shape that we can see here, because in this example we don't have the cutout, so I'm going to use the delete face tool to remove these faces. It just makes it around, and that's going to match the other side. So those two are now symmetrical. What else do we need to do? We do need to fill in, which means this part here, we need to move that to this face. So I'm going to use the Move Face tool, and I'm going to offset it. And let me just do a section view so I can show you exactly what I'm doing. I'm going to edit this Move Face feature. And I'm going to insert, update that or increase it until it is moved up to this face here. Now it's going to stop there, right? So even if I increase the number, you can see it's stopping because it's hit that other face. That's good for me. All right, it's filled in that gap. Anything else we need to tweak? Let's just check the thickness. It's 5.64. This is 2.8, 5.6. That's pretty good. Let's just make these slots balanced. So I'm going to delete face on the top and the bottom to remove those sections. And then I'll see if we can do a full round fillet. So I'm going to select face, face, face. Yeah. And then I can get that nice round slot in there, which, you know, is very, very close to what I can see here anyway. Like, it's really small, but it does look like a round slot that's in there. Now we do have to do that 4 times, but that's not too bad. Now, a quick tip for the selection boxes like this, when I click my first selection, I can right mouse button to get to the next tab. So you can do those selections very quickly if you're using that process, and then the enter key is going to repeat the last command. So you can go through and do those in a matter of seconds. All right. And there you have it. Finished part. Bit of hacking. That's another method, completely different to any of the Lego parts we've done so far, where we're inserting other parts into the file. What's good about this is if I did go and make changes to either of these to update them, say there was an issue or an error, those would flow through into this part file next time I opened it. So it is quite useful. Let's add a red configuration before we drop it into our assembly. Just going to update the part appearance to a red color. And insert in assembly. And what did we call this one? Here we go. All right. That would be our last part for tonight. If we just check our list, what we've got left, there's only a couple of parts that I'll model off stream. Some simple ones with configurations, a tire. We've already done a tire on stream before. So if you were curious to see how that was, please check out the previous live stream. The chapters will take you right to that section where I modeled the tire, so you can check that out. There's a gear. We have done a gear before. We did the large one, so I've got the small one to do, and a couple of the smaller parts. In the next episode that we do the live stream, we'll be doing the assembly. And so everyone that is on can join in at that time. So look out for the scheduled stream, jump on my Discord or the email list. I'll send out a notice. We'll try and make it a good, fun stream. But yeah, thanks for anyone that watched the video. If you have any questions about the project, you want to be involved, get in touch. Otherwise, have a good week. Thank you to those in the chat. Edward, Leaky, Guntis. Guntis, can't thank you enough again for the super chat. That's a she, as well. I appreciate everyone jumping on. So thank you and see you next time.